Okay, retro, go. Vital, go. Guide, go. Control, go. Telcom, go. GNC, go. Econ.
While the moon has always been an object of wonder and scientific interest to humanity, lunar exploration began in earnest in the 1950s, with the United States and the USSR developing and launching robotic spacecraft. In 1959, the USSR's Luna 1 was the first spacecraft to fly by the moon. In 1966, Luna 9 achieved the first soft landing, and in 1969, the US's Apollo 11 achieved the first human landing. In the decades since, many nations have contributed to lunar orbiters and landers. As of January 2024, 5 nations have successfully landed on the moon. But despite the incredible achievements, there was one aspect of the moon that remained out of reach: the far side. The far side of the moon has a certain mystique about it. It's eternally out of view, never facing the Earth, which has earned it a misleading nickname, the dark side, as if sunlight never reaches its surface. It's the section of the moon we'll never see for ourselves, not unless we hop on a spaceship and fly over there. But now, thanks to the James Webb Space Telescope, we can finally see what lies beyond the horizon, unlocking a new era of lunar exploration and discovery. Join us as we explore the mysterious realm of the moon's dark side, uncovering obscure details and highlighting our celestial neighbor's lesser-known features. Some people see a face in the moon, others see a rabbit or a toad. But regardless of what you see on the lunar surface, we all view the same side of our natural satellite. So, why don't we ever see the far side of the moon? To know why, let's look more closely at its relationship to Earth. The moon orbits in such a way that one rotation takes just about the same length of time as it takes for it to orbit around Earth. That is, the moon spins on its own axis once during its orbit around our planet. That leaves one side facing us during its orbit. The technical name for this spin-orbit lock is tidal locking. Of course, there is literally a dark side of the moon, but it's not always the same side. What is darkened depends on which phase of the moon we see. During a new moon, the moon lies between Earth and the sun. So the side we normally see from here on Earth that's normally lit by the sun is in its shadow. Only when the moon is opposite from the sun do we see that part of the surface lit up. At that point, the far side is shadowed and is truly dark. The far side of the moon was once mysterious and hidden. But that all changed when our first glimpse of the mysterious far side came early in the space race, courtesy of the Soviet Union's Luna 3 spacecraft almost 60 years ago. In 1959, barely 2 years after placing Sputnik 1 in orbit, Russian engineers managed to send the spacecraft, which was crude by today's standards, into orbit around the moon, and for the first time, we got a good look at the mysterious far side. Luna 3 took 29 film images of the far side in total, which were photographically developed, fixed, and dried on board. Remember, this was long before multi-megapixel cameras. Ironically, the film used had been stolen from American spy balloons, as it had to be sturdy and radiation-hardened. The spacecraft, using a combination of 2 camera systems, one wide field and one narrow field but higher resolution, and a crude onboard scanner, could then transmit the processed images, which were spot-scanned from the photographs, back to the receiving station in the former Soviet Union. Although only 17 of the 29 taken were transmitted successfully back to Earth, of which 6 were considered good enough for publication, they proved to be a revelation. Those 6 images covered 70% of the far side and opened a whole new perspective on the lunar surface. It was almost immediately evident that the dark patches that make the face of the man in the moon on the near side are almost completely absent on the far side. These dark patches are basaltic plains called mare, created by volcanic activity on the moon billions of years ago. Instead, the far side was littered with craters, even more so than the near side, and some of those craters were the size of small countries. The Soviets started naming many of the features they were seeing for the first time, an act which caused some controversy in what was known as the height of the Cold War era. We already had an inkling of one of those vast new craters, which is actually one of the very few mare on the far side. The subtlest hint of Mare Orientale, one of the largest impact craters known, seen on the limb of the moon, had been known of since its discovery by Julius Franz in 1906, and can be seen during good librations when that portion of the moon swings around towards us. The view from Luna 3 showed how vast an impact crater Orientale was, resembling a bullseye. It was almost 900 kilometers across, pretty much the length of the United Kingdom, give or take, and was caused by an asteroid impact, thought to be around 64-kilometer wide just under 4 billion years ago. The resulting giant crater, termed an impact basin, was subsequently filled with volcanic lava. In 1965, another Soviet mission, Zond 3, flew by the moon with a far better camera than Luna 3 possessed, and with the ability to conduct more detailed science observations, including spectroscopy. Zond 3 produced 23 very detailed photographs of the lunar far side, which enabled one of the first detailed maps of the entire lunar surface to be constructed. In the meantime, NASA was progressing its Apollo program at a phenomenal rate. Following the declaration by President Kennedy that the U.S. would place a man on the moon and return him safely to the Earth by the end of the 1960s, by December 1968, NASA was ready to send 3 people, including Frank Borman, Jim Lovell, and Bill Anders, all the way around the moon and back for the Apollo 8 mission. They became the first humans in history not only to escape from low Earth orbit, but also to see the elusive far side. This is how Lovell famously described the lunar surface. The moon is essentially gray, no color, looks like plaster of Paris or sort of a grayish beach sand. We can see quite a bit of detail. There's not as much contrast between that and the surrounding craters. The craters are all rounded off. There's quite a few of them. Some of them are newer. Many of them look like, especially the round ones, look like they were hit by meteorites or projectiles of some sort. When the Apollo 8 spacecraft flew around the far side of the moon, the signal to Earth was cut off for around 10 minutes. This loss of signal was a daunting time for the flight crew and mission control. Apollo 8 was alone and truly cut off from Earth, venturing where no human had ever gone before. As the astronauts came back around from the far side, a collective sigh of relief was breathed by many of the flight team at Mission Control in Houston. Charlie Duke, who was the lunar module pilot on the Apollo 16 mission, describes what it was like to be flying over the far side of the moon. In the words of Charlie, "The computer told us that we were out of contact with the Earth and that we had loss of signal. Then, all of a sudden, there was the sunrise. It was the most dramatic sunrise I've ever seen. In Earth orbit, you see the sun's glow on the horizon or the planet's atmosphere, and it gets brighter and brighter. The moon is different, though. There's instant sunlight with long shadows on the lunar surface. The far side of the moon was very rough back there. I would not have wanted to land on the backside of the moon." After the success of Apollo 8, Apollo 9 went back to vital low Earth orbital testing of the lunar module. So the next astronauts to visit the far side were Gene Cernan, John Young, and Tom Stafford, on board Apollo 10 in May 1969, just 2 months before the historic landing of Apollo 11. However, while flying over the far side of the moon, the trio of astronauts encountered something strange, which in the last few years NASA has been forced to re-explain thanks to conspiracy theory documentaries airing on US television. The facts had been well known since the 1970s. These strange events on Apollo 10 were manifest in the form of some very odd sounds. The radio systems on board the Apollo spacecraft were crude by modern standards, though state-of-the-art at the time. The command and lunar modules were relatively noisy environments, according to most of the astronauts, with bumps and bangs combined with the whirring of fans and engine noise. What the Apollo 10 crew heard through the radio systems baffled them. They described it as being almost like that made by an electronic instrument called a theremin, often used in creepy science fiction B-movies of the 1950s and 60s, as well as on the Beach Boys song Good Vibrations. Research has since proven that the sound was nothing more than an interference effect from those 1960s radio communications systems on board. With the onset of the moon landings, 2 astronauts would travel to the surface, while a third remained on board the command module to orbit the moon alone, though all of them got chance to orbit the moon and see the far side before landing. The solo orbital journeys of Michael Collins, Apollo 11, Dick Gordon, Apollo 12, Stuart Roosa, Apollo 14, Al Worden, Apollo 15, Ken Mattingly, Apollo 16, and Ron Evans, Apollo 17, who were the unsung heroes of the Apollo missions, are some of the bravest feats ever achieved by astronauts. They would spend days making quite detailed lunar observations from orbit, mapping features nobody had ever seen before. Al Worden is often quoted as saying that his time alone was some of the best he had during the Apollo 15 mission. According to Al Worden, the far side, the views at certain times when the sun and the earth are blocked out, are like nothing you could imagine. The sheer number of stars you see is incredible. It's like a sheet of white, and you know that every single one of them is a sun in its own right. A question often asked of the Apollo astronauts and flight teams is, why were all the missions just to the near side? In fact, the answer is so simple. As Charlie Duke says, we wanted to be in contact with the Earth, so we weren't able to land on the far side of the moon. Should something have gone wrong while the astronauts were on the surface, they would not have been able to communicate directly with Earth. This would not be such a problem today, as satellites could be put into lunar orbit to relay communications. The far side is of growing interest to scientists and potentially future planned human missions. Indeed, the possibilities for the far side of the moon are vast. For many decades, the astronomical and scientific community has wanted to put radio telescopes and optical telescopes on the far side. Observatories on the far side would be shielded from not only man-made radio interference from Earth, but also the glare of daylight on our planet. The telescopes could be built inside craters to avoid solar radiation, and would provide us with an unprecedentedly clear insight deep into the far reaches of the universe. Otherwise, we also have little true understanding of the processes that make the far side so vastly different in appearance to the near side. Thus, with NASA gearing up to send astronauts to the moon's south pole, there's never been a better time to be a lunatic. The surge of interest in lunar exploration is great news for planetary scientists, hoping to learn more about Earth's rocky sidekick. These are the burning questions they're dying to find the answers to. According to Noah Petro, a research scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and a project scientist for the Lunar Reconnaissance Orbiter, the fundamental question of how the moon formed and how that relates to the Earth is really the most important of the unknowns. Everything else comes after that. You can thank Apollo 11 for giving us our first insight into that mystery. The mission brought back 50 pounds worth of moon rocks and initiated decades of investigations focused on learning how the moon formed and evolved. Scientists used them to come up with the strongest existing model, that the moon began as a magma ocean, a giant ball of molten lava orbiting Earth. This in turn led decades later to the hypothesis that the moon was born out of Earth itself, when a giant impact with a Mars-sized object ejected debris into orbit. Further studies of the rock show the material that formed the moon also formed our own planet, adding more support to this idea. That's the most widely accepted hypothesis for the origin of the moon, but it's by no means perfect. There is no way yet to confirm a giant impact created the moon, and our sense of how the magma ocean cooled down into the dry, gray rock we see now is still very hazy. About 10 years ago, we discovered evidence of water on the moon, something that's a bit difficult to reconcile with an impact hypothesis. Getting to the bottom of the moon's past requires the sort of on-the-ground work we've done to unravel Earth's own history. Put the origin of the moon aside, Apollo moon rocks continues to challenge our understanding with another conundrum. Why aren't moon rocks as old as the moon? The moon is just over 4.5 billion years old, which makes it a mere 60 million years younger than the solar system itself. The early days of the inner solar system were chaotic and defined by the constant collision of solid materials as they whipped around the nascent sun, gradually forming larger and larger bodies in a process known as planetary accretion. Analysis of the rocks collected by the Apollo astronauts shows that most were created by impact events about 3.9 billion years ago, but almost none of them were dated to the moon's first 600 million years of existence. This is weird because impact events should have become less frequent as the planetary accretion process wound down, so you'd expect to find a lot more rocks formed from earlier collisions. This led scientists to hypothesize that the moon was subject to intense collisions about 3.9 billion years ago, a period known as the Late Heavy Bombardment, or more poetically, the Lunar Cataclysm. While this theory nicely accounts for the Apollo moon rocks, it also raises a big question. What caused all these rocks to start pummeling the moon? The leading model suggests that the outer planets used to orbit much closer to the sun, and as they moved outward, sent big rocks on a collision course with the moon. But an alternative theory posits that the cataclysm never happened and that the preponderance of rocks dating to 3.9 billion years ago is due to sample BS. The last 3 Apollo missions all took samples from 3 major impact craters: Imbrium, Serenitatis, and Nectaris. New evidence suggests that the samples used to date the age of each of these craters, which is crucial to determining whether a period of heavy bombardment occurred, may actually just be debris from the impact that formed the largest crater, Imbrium, about 3.9 billion years ago. So, the best way to settle the lunar cataclysm debate will be to visit craters where samples aren't likely to have been contaminated by the Imbrium impact, such as the South Pole or the far side of the moon. If most of those new samples are older than 3.9 billion years, it will cast the theory of the lunar cataclysm in serious doubt and also help scientists better understand conditions in the early solar system. Regardless, interest in the lunar South Pole as a landing site is mainly driven by the fact that scientists know the region hosts lunar water. Indeed, there's water on the moon, and NASA first found water on the moon in 2009. But we're not just talking about a little sprinkling of interstellar water. We're talking about troves and troves of water ice that could be sitting just beneath the surface, especially at the lunar poles. This is good news for future expeditions to the moon, which plan to use this water ice for everything from life support to rocket fuel. But for many scientists, the big question is, how did all that water ice get there? Well, nobody really knows yet. According to Paul Hayne, a planetary scientist at the University of Colorado Boulder, there are 3 main theories for how water originated on the moon. The most obvious theory suggests that the water ice was deposited by asteroid and comet impacts, where it vaporized and eventually made its way to the poles. It's also possible that ionized hydrogen from solar winds binds with oxygen trapped in regolith and is eventually released as vaporized water due to temperature fluctuations on the surface. Finally, there's a possibility that water was present in the material that originally formed the moon and was forced to the surface by volcanic eruptions. It could be that all 3 processes were at work, which makes it a question of how much water each mechanism contributed. Luckily, there has been some promising initial data. In 2009, NASA launched the Lunar Crater Observation and Sensing Satellite on a mission to impact the lunar surface at the South Pole. And this mission not only detected the presence of water, but it also identified a mix of other materials that are common in comets, suggesting at least some of the water hitched a ride on space rocks. To get a better idea of how much of the moon's water was brought to the lunar surface by comets, asteroids, or solar winds, it will be necessary to send a robot or human to take a sample and examine its isotopic composition. That's really the only way we can definitively associate that material with a source. But even if scientists can determine the origins of lunar water, there's still the question of how it came to be concentrated in the poles, a controversial topic, according to Hain. Currently, the lunar science community is divided on whether water that is vaporized during comet and asteroid impacts can travel across the surface of the moon or whether it becomes trapped in the regolith. The only way to know for sure is to return for further tests. One of the biggest questions facing lunar scientists is whether the moon houses alien life. Conspiracies about little green men aside, some scientists believe water stored under the satellite's surface may hold ancient microbes. According to Professor Christopher Palma, an astrophysicist at Penn State, one idea for the origin of life is that its building blocks were delivered by comets. There may be remnants of those in the ice on the moon. Scientists won't know for sure until they send a probe, or human, up to the lunar surface armed with a hefty drill. One enigma that's sprung up only recently has to do with the discovery that something massive is lurking underneath the south pole of the moon, below the largest impact crater ever made in the entire solar system. Scientists have no idea what it could be, but it's certainly big enough to affect the gravitational force exerted by the moon's mass. Predominant theories suggest it's some sort of heavy metal body from a projectile that impacted the surface a long time ago. But this is far from certain. And it's hard to understand what this mass is doing suspended underground. We know the moon's interior is still active to some degree, and heat should have caused this mass to shift around instead of staying trapped like Han Solo in carbonite. Put simply, the moon, once again, raises questions we're just not able to answer yet. Another stunning revelation showed there are earthquakes happening on the moon pretty frequently, otherwise known as moonquakes. Apollo-era seismometers installed on the surface measured these shakes from 1969 to 1977. That data has shown us that the moon is an active body, a far cry from the stale, lifeless rock many assume it is. We're already aware of a few phenomena that cause these quakes, like thermal expansion, tidal stress induced by Earth's gravity, and meteorite impacts. But with such limited data, we're not entirely sure how these processes work and exactly how the quakes behave. Moreover, there are other, shallower moonquakes without any obvious cause, which seem to be occurring more recently than the others. Petro suggests a global seismic network installed around the moon would be tremendously helpful in helping understand the trigger mechanisms behind all this tectonic activity. Such a network could cleanly identify exactly when these events occurred, where they originated from, and the effect they have on the rest of the moon. The 50-year-old data we're using now won't be enough to give us any good answers. In addition, scientists also believe that there's a reason we've only ever seen one side of the moon. It's tidally locked, which means only one side of it faces Earth. This is not uncommon for moons in our solar system, but it's still unclear exactly when this occurs, what conditions encourage it, and how it happens. So, in some scientists' mind, this mystery of tidal locking harkens back to the question of the origin of the moon and what was happening in early lunar history. It's another piece of the 4-billion-year puzzle. What's more, this mystery isn't just local to the moon either. As we continue to find more planets and moons outside of our solar system, it's important to figure out what sort of factors help incite features like tidal locking and decide whether potentially habitable worlds, like the TRAPPIST-1 exoplanets, really are hospitable to life. After all, if scientists can lift the veil on moon mysteries, we could have a better understanding of the solar system's history. The moon lacks much in the way of an atmosphere and hasn't been volcanically active for billions of years, which means its surface has remained relatively unchanged across the eons. In this sense, says Prabal Saxena, a postdoctoral researcher at NASA's Goddard Flight Center, the craters are like the pages of a history book of the early solar system, if only we could figure out how to read them. As mentioned previously, a prevalent theory of lunar formation says that our planetary neighbor was bombarded by space rocks about 3.9 billion years ago. If the samples from the surface confirm that there was a lunar cataclysm, this could also tell us a great deal about how the solar system formed. Not only would it suggest that the outer planets were once much closer to the Sun, it would likely mean that the Earth was bombarded too. This would have vaporized any water on the Earth's surface and killed any life that may have existed there. Strangely enough, the Moon also appears to have recorded early solar history. Just a few years ago, Saxena and his colleagues used the composition of the lunar crust to determine that our Sun likely rotated 50% slower than similar newborn stars during its first billion years of life. The Moon and Earth are largely composed of similar materials, but the Moon has notably less sodium and potassium. Using this evidence, Saxena and his colleagues ran simulations that showed how solar activity can either deposit or strip the Moon of these minerals, and then incorporated data about the relationship between solar flares and stellar rotation rates. According to the simulations, the Sun must have been rotating slowly to account for the levels of potassium and sodium observed on the Moon today. This data about the Sun's early history can also help explain things like how quickly Venus lost its water, how quickly Mars lost its atmosphere, and how it impacted atmospheric chemistry on Earth. As NASA and other space agencies lay the foundations for a permanent human presence on the Moon, there will be more big questions to answer, and the Moon is really just a small step toward the giant leap of unraveling the origin of everything we know. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.